All right, so our first question for $100, keep track. Let's see how many you can get right. All right, here we go. Usually there's some very, what is it called? Pensive music playing. Okay, I tried to make the question really large so you could see it. And as soon as you have a response, you chat me. I'm just taking attendance. Oh, I guess I should. I'm gonna take the I'm gonna make it so you can only chat me. So nobody can see your answer and cheat. All right. Okay, I got some answers coming in. All right, which scenario represents exponential growth? So you need to know that exponential growth is not linear. It's not the same exact amount of increase or decrease every time. It might be the same percentage. So that's a dead giveaway. Exponential growth is always some type of like percentage or a different amount of tripling or doubling, things like that. So if you answered three, you're a winner. Write down 100 points. You got $100. You got $100. Congratulations. Well done. I got a bunch of kids who chatted me that. So well done. All right, you guys ready for the next question? This one's worth $200, so keep track. This one's worth $200. I'm just going to put a dividing line here so I know when to stop scrolling when I'm checking answers. All right, here we go. Next question up. All right, I got some answers from Sophia, Stone, Naja, Indiana, Grace. No Grace. Carolina, Christian. All right, I think everybody's answered me. So here we go. The correct answer is 4. Congratulations, congratulations. Only one student missed that. And you have to be closer to 1, right? So 0.524 is not very close to 1. So for the student that got that one wrong, that is the reason why. All right, next question. This one is worth $300. $300. Good luck. Here we go. Ooh. Yikes. What just happened? I think my computer's a little glitchy today. But let's see, anybody got a guess here? Thank you. I got one answer so far. I know you got to do some math for this one, so get your calculators out. Grace, you can't give me two answers. All right, Kevin's back. We're on this question, the third question for $300. So hopefully you've got your calculators out. So if you're calculating, or see, how many more answers am I waiting for? Okay. All right, I got answers from Sophia, Carolina, Indiana, Christian, Stone, and Nasha. Okay. All right. So if Faith calculated Celsius at 68 degrees Fahrenheit, let me get my pen here, right? Is it working? Yeah, okay, there we go. So this is the input. This is the value for F. So in your calculator, you are typing 5/9 input 68 minus 32. That's what you should be typing in your calculator. Press enter and it will give you your answer. So hopefully, whoops, let me clear this screen off. Hopefully you chose number one. Number one, great job, great job. All right, so let me give some points. Kev showed up. Okay, I'm gonna put my dividing line here so I know when to stop scrolling. There we go. All right, next question, my friends. This one is going to be for 500 points. 500 points. If you're playing along and you're keeping track, good luck. Some of you have earned all of your points already. So here we go. Next question, 500 points. Hopefully you're using full screen so you can see the whole question. Sorry, I just want to screenshot this. All right, we got some answers coming in now. Okay, remember it's worth 500 points if you're keeping track. 500 points. All right. Oh, man. All right, I'm just going to scroll back here, see my answers so far. All right, I got an answer from Grace, Naja, Christian, Stone, Kevin. Ooh, the answers are all over the place. I'm getting lots of different answers here. I'm curious what happened. So I'm going to turn my marker on here and let's just get started with a little bit of thinking about the fact that this does not have a leading coefficient of 1, right? You need a leading coefficient of 1. So I'm going to use my division property of equality, divide everybody by 2. When I divide everybody by 2, this is my new sentence. Okay. I'm going to move this constant to the right side, and that will give me x squared minus 6x with a big space and an equals minus 3. Now, I think you guys remember the value that goes here and here, right? So it's half of b squared. Half of b squared. So hopefully you know what you're adding to both sides. Does anybody want to change their response? I didn't get any right answers for this. So, okay, there we go. So that's why I wanted to give you some hints here. Okay, now some answers are coming in, people changing their responses. Thank you, thank you. All right, I like that better. I like that a lot better. Technically, I'm not awarding you any points on my end though, because I had to give you some help. So no points for you, but now hopefully you're understanding that to complete the square, rule number 1, you have to have a leading coefficient of 1. And then after that, you can, oh my God, sorry. The Alexa alarm is going off in my house. It was so loud. All right, so you were adding 9 to both sides. And then you get a 6 over here, right? You're going to get a 6 over here. So even if I didn't remember how to compute this part, I know that these are all incorrect, right? So you're getting a 6 over there. Okay, hopefully that helped. Let me clear my annotations. The correct answer was number 1. A lot of you got it on your second time around. Congrats, congrats. All right, I'm going to write my line here so I know when to stop scrolling. Okay, we're on to $1,000. Now in the real game, this is a benchmark. So if you get it right, even if you lose from now on, you still get to keep your $1,000. So as soon as you get a question wrong, you're out. But don't worry, you can keep playing with me. All right, here we go. Sophia, you have violin lessons in like 5 minutes. Sophia Henderson, did you hear me? You have violin lessons. Okay. Sorry. My kid's like living her best life, chilling on the couch. Got some different answers. Okay, got some different answers here. People changing their answers. All right, that's great. That's great. Change your answers. $1,000. $1,000. Not too shabby. All right, waiting on any more answers here. Okay. All right, I'm going to close it out, but I'm hoping that you understand one major piece of information here, and that this is a difference of 2 squares. Every difference of 2 squares has to have a plus minus combination. Just knowing that one simple fact, that a difference of 2 squares has to have a plus minus combination, all of these can be eliminated. You literally don't even have to know how to factor if you know that fact. If you know that you have to have a plus minus combination, you already know the answer was 2. But if there were more than one plus minus combinations, you would have to understand that this had a GCF of 4, which is why this number's out here. And that left us with 4x squared minus 9. And that's why we have a 2 and a 3, because we square root the first, we square root the last, and we put a plus and a minus in the middle, right? Okay, that's a mess, but basic knowledge of difference of two squares could have gotten you an answer to this question. So congratulations. If you chose number 2, you got 1,000 points. All right, let's move it along, move it along. This one is worth, oh, we got to our milestone, right? You reached the $1,000 milestone. Woohoo, still in the game. Now we got $2,000, or points, I should say. All right, get your reading glasses on. All right, some answers are starting to come in for 2,000 points. What do you think is going on in this function? All right, I got 4 answers so far. So one thing, I'll wait about 10 more seconds and then start giving you some hints. All right, here's your first hint. One thing we know about exponential functions, which is what this is, right? This is an exponential function. And one thing we know about exponential functions is if the value inside the parentheses is less than 1, then this is decay, right? This is decay. So that means it can't be an increase. Can't be an increase because this is decay. So that automatically eliminates choice number 1. Okay. Second, the W represents the number of weeks since training began, right? So if he's starting 20 weeks out, then the next week is 19 and 18 and 17, etc. Okay, so it's not how many weeks are left, it's how many weeks since he began. So 4 is out. Now this one's a little bit tricky because at a rate of decay of 0.90, that means the decay is 10%. It is 10%. But that's not how much he's running. He's not running 10%. He's running 10% less than whatever that other number is. So that's why they put this choice in here, because 10% is important, but it represents that each week he's running 10% less than the previous week. So technically, the answer is 3. If you chatted me a 3, congratulations. All right, let me clear my screen here. Keep it moving. All right, 3 was the right answer. Okay, we're up to 4,000 points. Good luck. Oh, I got to put my line divider in. Oops, Sophia's too fast for me. I still see it though. Oh, and Kevin's too fast. There we go. Okay. I see what you wrote though. Sophia, Kevin Stone, thank you. This topic is called solving for a specified variable. And I think you guys are really comfortable now with those little tiny subscripts. You know they're not math. They're just like a last name, a different differentiation from one letter to the other letter. So if you're solving for P sub 2, that's how you pronounce it, P sub 2, then all you have to do is get rid of V sub 2. Thank you, Grace, Nasha. All right, so in order to solve for P sub 2, you need to undo timesing by V sub 2. So we are dividing both sides by V sub 2. So that means 3. Fantastic, 3. So $4,000 to you guys who chatted me that 3. Let me clear my ink and we'll move it along. Great job. Okay, next question. 8,000 points. All right, here we go. All right, the answers are starting to come in. Thank you. Let me chat back here. I don't know if I can give you those points now, Kevin. You had to ask me that question. All right. Let's talk about the domain. The domain is the input. The input in this case, X represents the number of complete products. So not partial products. So partial is a ratio. So anything that's partial is a ratio. So a ratio is a rational number. So if you have positive rational numbers, you can be 1/2, you can be 3/5, you can be 17 seconds, something like that. But rational numbers are not complete products. So this one's out. Okay. Integers, which would be a complete product like 1, 2, 3, 4, or -1, -2, -3, -4, doesn't make sense because you're not going to produce negative products. So integers is out. And then we come down to positive real numbers. Now I need you to understand that real numbers is all of the numbers. And then inside that you have rational and irrational. So if you say positive real numbers, that means you can have 1, you can have 1.5, you can have 2.7, you can have -3, or no, not negative because it said positive. But anyways, real numbers also includes square root of 2. Real numbers also includes the square root of 2. So that one is out. The final answer was 4. If you chatted me a 4, congratulations. 8,000 points. 8,000 points. All right, let me put my line divider here. We're on to our next question, worth 16,000 points. Let's go. All right, got some answers coming in. Thank you, thank you. $16,000 points. I got an answer from Sophia and Christian and Peyton and Indiana and Naja. Thank you, thank you. I'll wait about 7, 8 more seconds. All right, let's talk about this here. It's telling you that this variable A is going to be your new leading coefficient. So I have something here, and A has to be any number that's greater than 1. So it could be 2x squared, it could be 5x squared, it can be 7x squared, it can be 2.5x squared, it doesn't matter. But we know that it is greater than 1, therefore it is positive. So anything that is positive is going to be an upwards facing parabola. So we know that already. Our common sense is that it's a positive coefficient. Positive coefficients are upward or concave up. So 3 and 4 are out. The only way for any parabola to be facing downward is for there to be a reflection, and that means you need a negative sign in front of your x squared. And we don't have that. So 3 and 4 are out. Now, the next thing is a little bit tricky because when I was talking to one of my other students, I don't know if you can see my picture, but some students think a stretch is left or right. But actually with parabolas, the stretch is up and down. So if you are stretching, you are making it more skinny. So if you are stretching, you're making it more skinny. And if you are flattening, right, that's flattening. That is compressing it down, pushing it down, making it fatter. So hopefully you understand that if A is greater than 1, it's going to be more skinny. And if A is a fraction, that means it's between 0 and 1, it's going to be more fat. Fractions are flatter. So we know it is higher than 1, so it's not a fraction. And we know that it's facing upward. So this one is going to be A2. It's going to be A2. I know people are changing their minds now. So hopefully now you understand what that coefficient does, right? Coefficients that are positive are up. Coefficients that are higher than 1 are narrow or stretched by a factor of whatever that number is, stretched by a factor of. All right, I'm going to put my dividing line in here and we'll continue on to our next question worth $32,000. Good luck, my friends. Where's the question? Oh, no. Okay, we'll have to skip this question. Sorry. Eek. I don't know what happened there. I clicked too fast and it showed you the answer. All right, $64,000. $64,000. We can handle this. All right, Francois has 14 quarters and dimes. If the total value of the coins is $1.85, find the number of each coin. Okay. I know this one's formatted a little different because this one would not be a multiple choice question. This one would be a constructed response, a do it yourself. So if you're stuck, let me give you a hint. She has 14 quarters and dimes. So quarters plus dimes equals 14. It also says that they are worth $1.85. But since this second clue is about money, your variables have to be about money. So it's 25 cents per quarter and 10 cents per dime. This is your setup. This is a system of equations. We have two unknown variables, and we have enough information about each variable so that we could solve this. Got two techniques from here. You can use elimination method, which is very popular, or you can use substitution method. So I'll give you some time from here. I know I took the choices away. Oh man, hold on. Let's see if I can put them back without giving away the response. Hold on, pause my screen. All right, here come the answers back. Sorry, there we go. Okay. I don't know. I kind of love the elimination method. That's just like always my go-to. But I see here, like I'm about to be strategic though. Like literally, I'm about to be strategic. This is something good for you to kind of understand. You could certainly, because this is multiple choice, you could certainly guess and check. You can certainly look at all of those combinations, times them by their values, and you can guess and check. But strategically, using the elimination method, do you see how both of these answers have 7 quarters? Well, if there literally are 7 quarters, then, and me finding out how many quarters there are, that's not going to help. But when I look at the dimes, I notice that none of them have the same answer for dimes. So 7, 1, 11, and 8. So strategically, I'm thinking, hey, I should find out how many dimes there are. So that means I want the Q to go away. So I'm actually going to multiply everybody up here by negative 0.25, negative 0.25, negative 0.25. Whoops, my thing got in the way. And when I do that and I rename it, that allows me to get the elimination of something strategic, right? So I'm going to get negative 0.25 quarters minus 0.25 dimes equals, I need a calculator, 14 times 0.25, negative 3.50, right? There's my system, there's my elimination. So I've got negative 0.15 dimes equals, oh shoot, I gotta do that again. 1.85 minus 3.5. I got negative 1.65. Divide that by 0.15. Ooh, I get 11 dimes, see? So that was a strategic choice for me. By looking at my multiple choices, I noticed that the dimes were all different. And if there are 11 dimes, that means there has to be 3 quarters, which makes sense because if I go back and substitute in an 11 here, then that means that the missing value is 3. The missing value is 3. All right, I'm going to clear my annotations now. Hopefully that was a good refresher for you. I know I took the question away to give myself some space to write, but hopefully that was a good refresher for you on translating a system of equations and what do you call it? Using elimination or substitution methods. So B was the right answer. I know I had to give some advice and helpful hints there. I know Sophia got it without my help. Okay. Grace and Peyton. Just keeping track, just keeping track. All right, Kev. Okay, here we go. My little line divider. And we're going to like our last few questions. Woohoo! All right, 125,000 points. Here we go. What is the minimum value of this function? This is a fast one, technically. Good job, Grace, Sophia. All right, in case you didn't get it yet. One way you could do this is by using your graphing calculator, although it's not necessary, but hey, you know, when you're stressed and you're like, I don't know what to do, you should bust out your calculator. So just as a reminder to you, because I know some kids forget because we don't use this button very often, is the absolute value button can be found in a couple of places. One is it can be found in the fraction menu by pressing alpha, y equals, and arrowing over one time, so you can find it there. Or you can press the math button and arrow over one time and find it there. So that's the absolute value bar. You could type x plus 3 inside and then minus 2 outside. You can certainly take a look at your graph and you can see that vertex or that turning point. So that is the minimum, how far down it goes. And if you can't tell from the pixels, you can always second trace and calculate the minimum there. And then you want to be on the left side of the minimum. And then you want to be on the right side of the minimum. And then you take your guess. Okay, so hopefully you know that the minimum is the y value only. And if you weren't using a calculator and you were just looking at this function, which is in vertex form, you know that vertex form is the opposite of the number inside the quantity and the same as the number outside the quantity. So there's your vertex. We already know just by looking. We didn't even need our calculator. We already know by looking that the y value of the vertex is -2, which is choice number 1. So congratulations to those of you that chose choice number 1. Payne asked a good question. Let me pull my calculator back up again. I don't know where it went. I guess I closed it out, but let me pause my screen for a second. I'm in my, okay. Kev's like, my computer's dying. I'm like, so's mine. Oh, here it is. Okay, share back. Okay. Peyton asked a good question. She's like, I'm looking at my calculator, but it totally does not look like yours. Maybe it looks like something like this. And you're looking at it and you're like, what the heck? Or sorry, that's not even that bad. Anyways, if you're looking at it, it looks different. You can always press zoom 6. Zoom 6 will always take you back to the 10 by 10 screen. Okay, Peyton, that's a good question. So if you want to get back to the main zoom, you press zoom 6, zoom standard. That will get you back there. All right, kids, let's keep moving. Let's keep it moving. Next question. So that one was a 1. Congrats to those of you that got it. Now we're up to $250,000. Woohoo! All right, here comes the next question. Sorry, my calculator was in the way. Sorry, kids. Your teacher is the worst. All right, we got some guesses coming in. Some people wondering. This is worth how much? $250,000. Oh, wow. Okay, so let's start talking. The cost to mail a letter was 49 cents for up to 1 ounce. So if you half an ounce, 49 cents. 3/4 of an ounce is going to cost you 49 cents. So no matter what, you mailing that initial value is 49 cents. That initial value is 49 cents. Just knowing that alone should be enough for you to be like, okay, that means the first value has to be 49. So we can eliminate everything already here, but so it's going to cost you 49 cents no matter what. And then after that, you're going to add 29 cents for every additional ounce. Okay, so if you have this function here and you mailed 1 ounce, right? Well, that would be your initial 49 cents. So then every ounce after that is the additional 21 cents. Every ounce after that is the additional 21 cents. Okay, so it is 1. It's 49 cents for the first one, because that's the initial value, and then 21 cents plus after that. All of these over here, right here, these are saying you're going to add 49 cents, but that's not true, right? So we know we're going to be adding 21 cents. But the initial value is 49. Okay, let me clear my annotation. We're on to our last 2 questions. All right, here we go. $500,000. All right, you guys got this one. You got this. Okay, I got some answers coming in. I'm hoping that you're like, oh, this feels so easy. It seems like a trick. It is so easy. You should feel so confident. This should have been a $100 question. I know. I think what happened was I literally made this game in under 10 minutes. So I wasn't really strategically thinking of where to put the questions. I was just like, copy, paste, hurry up. You got to get online. All right. I did not get 100% right answers. So I'm like, what? Remember, a 0 is a synonym for a, right, this word here, 0, my pen's not working. Zeros are roots if you're using the quadratic formula. They are x-intercepts if you're looking at graphs. They are solutions, right, if you're solving something out. So roots, zeros, solutions, they all mean the same thing. The correct answer is 4. I didn't even check these. I did not even put them in my calculator to check, because I literally can see that this touches at 2 and it crosses at -4. And so those have zeros at those locations. So the answer was 4. Congrats, congrats, congrats. Almost everybody got that one right. All right, here we go. That was a big screenshot, but you can see the 4 down there. Okay, guys, ready for the $1 million question? All right, you're about to, I know this question is easy, so don't overthink it. I put it in the wrong order. Should have definitely been $100 question, but let's end on a high note. Let's get ourselves $1 million because you've earned it. Here you go, my friends. One, two, three, four. Almost everybody's chatted me. 5, 6, 6. Why is there a question mark there? Come on, you're confident. You are confident. You know this. Don't second guess yourself. This is not the time. This is not the time. Okay, we're at the finish line. Go with your first instincts. Don't stress out and start second guessing yourself. All right, that's some good Regents advice, because you're going to be like stressed out and you got to say, go with my first instinct. Go with my first instinct. You should never change an answer unless you have a very good reason to. You should be like, oh no, I made a math mistake. That's why I'm changing my answer. But you should never change your answer because you're like, I don't know. I'm not sure. Could be that. That's a good looking wrong answer. All right. Remember that when you are solving quadratics, which is what this is, it's in factored form, that your factors are the opposites, right? Because you split it into 2 equations. Your factors are the opposites of your answers, right? +2 + 2 + A + A. So hopefully you got the right answer, right? +2 + 2 + A + A. That's why the answer was 3. Did you just get $1 million? Because I think you did. Congratulations. You won $1 million. Now you're rich. I wish I had $1 million, man. Wouldn't that be nice? That'd be so nice. All right, kids. So those were my questions for you. I do have some more time if you'd like to stay on with me. I was thinking of going over some other worksheets. The 2, the 1s, the 0s that I handed out, because I don't think I posted those answers yet. But I am curious, you can chat me or you can unmute your mic. Is there anything that you need from me that you would like to review? Am I going to be in class on Monday? Yes. Is that what you mean? I'll be in class on Monday and Tuesday and Wednesday and Thursday and Friday. Domain and range, arithmetic sequences. Okay, keep them coming, kids. All right, Kev. He's gonna go live his best life today. Thanks. Oh, recursive formulas. Okay, I'm jotting this down. I'm jotting this down. By the way, the winner today was Sophia, FYI. Quadratic word problems. Okay. Domain and range, sequences, recursive, quadratic word problems. All right, I can pull up some information on all of these. Any other things? I didn't hear from everybody yet. Or second things from people, second topics that you're feeling kind of iffy on. All right, let me get my, you can't minimize when you're recording this Zoom. Okay. What am I doing? Sorry, wrong thing. Let me close my PowerPoint. We're done with that. Don't save. Okay. Did you guys try the worksheets 2, 1, and 0? Did you try any of those things? Do you want to look at any of those answers with me, or you want to just go into your questions? Give me a majority rules here. All right, I'm going to start with sequences and recursive formulas, but I don't want you to like freak out. It's not like a huge topic. All right, bye, Kev. Have a nice day. Oh, I've got to take my thing off. I can take it to everyone. Have a nice day, kiddo. Now you can chat with whoever you like. Oh, right. Okay, got that. Let's see. What am I doing? Let's take a look. No, not this one. Recursive, here we go. Okay, I like this question. Let me open my notebook file. Okay, I'm gonna put up a question for you here in a sec. I'm just waiting for the Smart Notebook to open. And this is another Regents question on recursive formulas. So let's see what you think of this one. It also has to do, recursive formula are sequences. So hopefully you see the connection there, but here we go. Let me share my screen with you kids. I'm about to sneeze. All right, here we go. Sharing. Okay. Let's take a look at this one. I'll give you a second to read it. So a major difference. Hold on, I'm just chatting something. Okay, the main difference between an arithmetic sequence and a recursive sequence is an arithmetic sequence, you can jump to any number that you want. You want to know the number in the 50th place, you can jump right to it. The formula will take you right there. With a recursive formula, you must do the previous answer before you can get the next answer. So hopefully if you're taking a look at the one that you see on the board on the screen now, hopefully if you're taking a look at this, you understand that the first number in the sequence is 5. And then if I want to find the second number in the sequence, right? If I change this to a sub 2, right? If I change that n to 2, then I want to find, sorry. If I have the first number in the sequence, let me back up a second. If I have a first number in the sequence here, by putting a 1 here, then 1 plus 1 would be a sub 2. So to get a sub 2, I have to multiply 2 times a sub 1. So to get a sub 2, I'd have to multiply 2 by the previous number, which is 5. So 10 minus 7 is 3. So I had a 5, the next would be 3. And I'm going to do that again. To find a sub 3, I'd have to put a 2 here. A sub 2 plus 1 is 3. And that means I'd have to have a 2 over here. And a sub 2, this time when I plug it in to my formula, a sub 2 is not a 5. A sub 2 is 3. So my first value was 5. My second value was 3. My third value will be 6 minus 7, which is -1. And now we're going to find the answer for the fourth position. To find the answer for the fourth position, let me erase my mess up here. This would need to be a 4. But in order for the 4 to be there, I don't put a 4 here. I'd put a 3. So anywhere the letter N is, has to be replaced with a 3. So I'm going to multiply 2 times a sub 3, which for us is a -1. 2 times -1 is -2, and -2 minus 7 is -9. And that's how recursive formulas work. This is a pretty sophisticated one. This is pretty challenging, but it requires you to use the number from the previous answer. So this is kind of messy. Let me give you another one, okay? I'm going to pause my screen for a second. I'm going to go screenshot another question. Okay, let's see. All right, here's one. What happened? Okay, take a look at this one. Here, I just changed it. This will be our last recursive, and then we'll go on to something else. After this, let's see, what can I do after this? Domain and range. We'll do that next. All right, anybody got some thoughts about this question? Anybody? So the answer in the first position is 3. That's what this is telling you. The answer in the first position is 3. I know there's no a sub 1s, but instead of a sub 1, they're writing it like this, f of 1. The function in the first position has an answer of 3. So the first answer is 3. They want to know 5. So this is the first answer. This would be the second answer. This would be the third answer. This would be the fourth answer. This would be the fifth answer. Answer is A. Answer 1, answer 2, answer 3, answer 4, answer 5. Problem is with recursive formulas, you can't just jump to answer 5. You actually have to find all the previous answers. So here's the function. I'm going to multiply -2 times something, and then I'm going to add 1. That's the function. I'm going to multiply -2 times something, and then add 1. I'm going to multiply -2 times the previous answer. That's what this means. So if n is the second answer, to find the second answer, you need to do 2 minus 1, which is the first answer. You see that? So if you're trying to find the number in the second position, then this function rule is 2 minus 1 or 1. So you do know the answer in the first position. So every time, this is your rule. -2 times the previous answer plus 1. So now that you know that, give this a try. I'll give you about 60 seconds, see how far you can go. -2 times the previous answer plus 1. So to find the answer in the second position, good question. Naja asked me a very good question. This has an F and a parentheses. It's not math. This -1 is not math. The -1 inside the parentheses here is telling you where in the sequence you are. So -1 means you are 1 backwards. So you're going to go whatever number you're at, you want the second number? Well, go 1 backwards. That's how I say the phrase previous answer. This outside here, whoops, this right here, that's math. This right here, that's math. But this right here, that's directions as to what number should go in here. That's directions as to what number goes in here. And n-1 stands for the previous number. So if I'm n-1 is behind me, n+1 is after me. That's what that stands for. Okay, so answer before me, answer after me. So for the first move for you guys, the formula is -2. And if I want to find this answer, I need to use the previous answer. So that goes here. -2 times 3 is -6. -6 plus 1 is -5. So that's the answer here. Then we do this all over again. But remember what goes in this spot? The previous answer. So my answer here is going to go there. So -2 times -5 is 10. 10 plus 5 is 15. So this is a 15. I'm going to do it again. Oh, whoops, sorry, I messed up. That's supposed to be a 1. Back it up. Back it up. Plus 1. -2 times -5 is 10. 10 plus 1 is 11. The 11 is going to go here. Same rule. -2 times the previous number plus 1. -2 times the previous number, -22 plus 1. Again, -2 times the previous number plus 1. -2 times the previous number plus 1. So for me, -2 times -21 plus 1. So that's 42 plus 1, which gives me 43. All right, this is a tough question, but if there's anything you're going to get wrong, this could be it, right? These are those really tough questions that really separate the kids that understand everything from the kids that understand most of the things. So I really don't want you stressing about this topic. Recursive formula, the most it would ever be is 1 question worth 2 points, okay? It's just 1 question. So don't stress out about this topic. I'm going to switch to the domain and range, mostly domain, because when you say domain and range to me, I'm not really sure which topic. There's actually 2 topics. Domain on a graph, and then domain in a word problem, like this one. Officials in a town use a function to analyze traffic patterns. The function, C of n, represents the rate of traffic through an intersection, where n is the number of observed vehicles. So all I really want you to understand is that is the input, and the domain is your input. So if the input is the number of observed vehicles. You have to know what that means. The number of vehicles you saw. Well, did you see half a car? No. Did you see -2 cars? No. Did you see -1 cars? No, right? So there's this topic on domain. This topic on domain has to do with potential input values. So one of the problems when we were working on in the game today, it was complete products, right? So they used words, whole numbers, real numbers, rational numbers. And this time they didn't use words, they used actual sets of numbers. So hopefully you're understanding that the answer to this question is 4 because those are whole values. Now, if this question was about the time of day, well, then you could have partial numbers like this. You could see a car 30 seconds or half a minute later. So each question is different. Then we have the type of domain and range questions, which are like this one here. This function represents the height in feet of an object from the ground at t seconds after it is dropped. A realistic domain for this function is. Okay. So if something is being dropped, it typically, right, if you're standing on a building and you're dropping something, it would typically look like this. And if we're thinking about this as a graph, this is your input, this is your output, right? This is your X and this is your Y. And you need to know that this is the input, right? The number inside the parentheses is the X. So this is time. And that makes this one height. So let's start thinking about, all right, if I drop something from the top of a building, can I have positive time? Yes. Can I have negative time? No. So anything that has a negative number in it wouldn't be realistic. So we can't have this because that's all of the numbers that you can think of. We can't have this because it has a -3 in it, right? It has a -3 in it. So we can't have this. And that leaves us between these two choices. So technically, a domain is just your t value, not your h value at all. See this one right here? That has an h and a t in it, so that doesn't make sense. The time is from 0 to 3 seconds. That would be realistic. So the answer to this question is a time between 0 and 3. Time between 0 and 3. Let's see if I can't give you one more to think about like that. Okay, here we go. Here's one more. This one might be good to try. Let's see. Copy, paste. All right, what do you guys think about this one? Okay. So hopefully you remember what I was pointing to, right? The domain is that item inside the parentheses. It's the input. And for us, it's a P. You have to know what P stands for. So hopefully you know P is the number of people. Start thinking logically. I'm talking about the number of people working at this construction company. Is the number of people negative? No, right? So that's where you start your logic pattern. It can't be negative, can't be negative. So these are out. So we know we've got to have a positive person. The question is, can you have partial people? Partial people? No, you can have partial people. So that's why the answer is 1 here. All right, what's next, kids? What else did you want to work on? I know there was, quadratic word problems, right? I think somebody said that. Can I pull one of those up? Give me a hot second. I will be right there. Quadratic word problems. I'm assuming like, let me think what you could be thinking, like find the time when something hits the ground or something like that, maybe is what you're kind of referring to. Let's see if I can't find something like that. Quadratics. I think this might be what you were talking about, Christian, when you asked for like a word problem. So I'm put this up. You tell me yes or no, like, no, that's not what I meant. It's a little bit blurry, but I think you guys will be okay. Sorry for the blurriness. Here we go. Not so blurry anymore. All right, is this kind of something you're thinking? Okay, good. I got it. See, I know these things. All right, kids, let's see what we can do. Okay, if you're feeling anxiety right now, I'm hoping you kind of understand this. The rocket is shot up in the air and it's coming back down. So hopefully you're at least envisioning this in your mind. Okay, so if we're looking at a graph here, we don't want the graph to go below the ground, right? And it's not going to start in negative seconds. So this is kind of like what we're looking at here. I know I've got a fancy formula. And I know that this is always time and this is always height. So what are they asking you to find? Determine the number of seconds. Does that make sense? They want to know the time, but they're giving you the height. Time is the unknown, height is given. Time is the unknown, the height is given. So when you're looking at this formula, time is unknown, but height is given. So you should erase and replace. So this is the one major kind of piece of information I want you to understand. What are you trying to find? Right? We are trying to find the time or the t value. The only way you can find a t value is if your sentence is equal to 0. And our sentence is not equal to 0. Our sentence is equal to 529. It also says to solve algebraically. So your choices are factor, square root by completing the square, or the world's best choice, which is the quadratic formula. Put it here for you in case you want to use it. There it is. It's always on the reference sheet. You never have to memorize it. But this sentence is not ready to be solved because it's not equal to 0. You cannot use this unless this has a 0. rule number 1. So I'm gonna let you do some number crunching. See how you do. All right, how you guys doing? Were you able to manipulate your sentence? Here we go. I'm going to share with you the work that you would show. If this was a short answer question and you were showing algebraically using the quadratic equation, this would be the only work you need to show. That you've identified A, B, and C correctly, that you've inserted them into your equation formula correctly, and then you bust out a calculator and you type it all in. All right, take out your calculator and you type it all in. So here's my calculator. I typed it in. Did anybody else get an answer? All right, nice job. I also got that, Christian. So when I type it into my calculator here, I get a fraction. That's because, all right, Peyton, see ya, because I entered my math as a fraction, but you can always convert it or divide it yourself by pressing math, convert it to a decimal, and you can get 5.75 seconds. So that would be the answer that you'd have to you'd have to write that down. You would have to write 5.75 seconds and circle that at the bottom of your paper. I don't know why my marker changed colors, but that was weird. All right. Hopefully that was enough to kind of refresh your memories on what you need to work on. Any other quick questions before we go? Anything you want me to prepare for you for Monday or Tuesday? Because that's our last chance to be together. So let me know and I'll work on it this weekend if there's something in particular you really want to still go over with me. For you guys that are still on the call. You good? Type in one question, the answer you got the same as the axis of symmetry. One question, is that answer you got the same as the axis of symmetry? Are you asking the one I was just showing you? The one about the rocket? Okay, no. So let me share that back with you for a second so I can just make sure I'm clear about that. Where is it? Here we go. Okay. So in this question, let me scroll down a second. I had my rocket, right? My rocket was being launched, and it literally was just asking me, at what time will it be this high, 529 feet? That was the question. At what time will it be that high? I don't know if 529 feet is here or there. It could have been the vertex. It could have been, but it wasn't necessarily the vertex. So the axis of symmetry would have to be the vertex. I didn't do the math to find out the vertex for this rocket, but it absolutely could have been that maximum point. But the axis of symmetry would not have been found using the quadratic formula. The axis of symmetry is found by using this formula, negative b over 2a. So that would have found the actual maximum height of the rocket and at what time that maximum height would have occurred. So if I go back and look at my values, B was 184 and A was negative 16. So negative 184 divided by 2 times negative 16, right? I could do that math. I got my calculator off on the side here. So 184 divided by 32. Oh, it is. It's 5.75. So this happens to be the actual vertex, which would be the axis of symmetry. So I guess the answer to your question was yes, it is the same as the axis of symmetry, but only coincidentally. They didn't necessarily say that this was the maximum point, but in this case it was. Does that answer your question? I hope it does. All right, anything else? You guys good? All right, I'll see you Monday. Take care.